Everything your computer does. Every click, every app, every task starts with RAM. Let's dive in.
RAM is your computer's short-term memory. It holds the data and tasks your system is working on right now, so it can access them almost instantly. When you open apps or switch between tasks, RAM stores that data temporarily, and it clears out when the computer shuts down. More RAM means smoother multitasking, faster programs, and fewer slowdowns. If your system feels sluggish, upgrading RAM is often the quickest fix. The RAM stick is the actual hardware that stores this fast, temporary information and helps keep your computer running smoothly. It has several black memory chips on top and gold contacts along the bottom. The notch in the contacts ensures it only fits into the motherboard one way. Labels like DDR4 or DDR5 indicate the memory generation. RAM and storage do different jobs, and your computer needs both. RAM is your fast, short-term workspace. It holds what you're doing right now and clears when you shut down. Storage, like an SSD or HDD, is your long-term memory. It keeps your files and apps even when the power is off. Basically, RAM is where your computer works. Storage is where it remembers. DIMM and SODIMM are just two different shapes of RAM. DIMMs are the larger modules used in desktop computers. SODIMMs are the smaller, compact modules used in laptops. Same job, different size, depending on the device. And just as a quick note, most desktop DIMMs are UDIMMs, which simply means they're the standard unbuffered memory used in everyday PCs. DDR stands for double data rate. It's a memory technology that sends data twice per clock cycle, so it can move more information without needing a faster clock speed. Each new DDR generation improves on the last. It runs at higher speeds, uses less power, and provides better bandwidth. That's why modern computers use DDR4 or DDR5. They're faster and more efficient than older versions. DDR memory comes in different generations: DDR, DDR2, DDR3, DDR4, and DDR5. Each generation gets faster and more efficient, giving your system better performance and bandwidth. Every DDR version has a different notch position, which prevents you from installing the wrong type. And this is important because motherboards only support one DDR generation. You need to match your RAM to the exact DDR type your motherboard is designed for. DDR generations don't mix, and they don't fit in each other's slots, so always install the correct DDR version for your system. So what's the difference between DDR4 and DDR5? DDR4 has narrower bandwidth, so it moves less data at once. DDR5 expands that bandwidth, letting more data flow and boosting performance. DDR4 offers good speeds, but DDR5 delivers higher transfer rates, making it stronger for gaming, multitasking, and modern workloads. DDR5 is also more efficient, using power smarter thanks to its updated design. DDR4 works well, but it can't match DDR5's improvements. Motherboards support only one type of RAM. DDR4 boards can't use DDR5, and DDR5 boards can't use DDR4. Simply put, DDR4 is reliable, but DDR5 delivers faster performance and better efficiency. Knowing the difference helps you choose the right RAM for your system. Let's talk about ECC RAM, the type of memory built to catch and correct errors before they crash your system. ECC RAM stands for Error Correcting Code Memory. It includes extra data bits that allow the system to automatically detect and correct memory errors. This makes the system far more reliable, reducing crashes, preventing data corruption, and avoiding unexpected failures. ECC is mainly used in servers, workstations, and mission-critical environments where stability and data integrity are absolutely essential. Non-ECC RAM is the regular memory you'll find in most desktops and laptops. It's built for everyday computing tasks and doesn't include any error correction features. Since it can't detect or fix memory errors, it's not used in servers or mission-critical systems where stability really matters. But for normal consumer computers, non-ECC RAM delivers solid performance at a lower cost, which is why it's the standard choice. Memory channels are the data pathways between your RAM and the CPU. More channels mean more bandwidth, so dual-channel or quad-channel setups let your system move data faster. Just make sure the RAM sticks are in the correct slots, or the extra channels won't activate. Single-channel and dual-channel matter more than people realize because they determine how many data lanes your RAM can use to communicate with the CPU. Single-channel memory uses one data path, so bandwidth is limited and performance is lower. It works fine for basic tasks, but it's not ideal for heavier workloads. Dual-channel memory uses two parallel data paths, which increases bandwidth and makes the system feel smoother, especially for multitasking, gaming, and productivity. Quad-channel memory uses four active data lanes between the RAM and the CPU, which massively increases bandwidth. It's designed for high-end desktops, workstations, and servers where heavy workloads demand more throughput. But quad-channel only works if the motherboard and CPU support it, so the hardware has to be built for this configuration. Quick note: triple-channel memory was only used on old Intel x58 systems, but modern PCs don't use it. Today, it's all dual-channel for mainstream builds and quad-channel for high-end workstations. Performance now comes from faster DDR generations and higher memory speeds. Let's do a quick recap of RAM. RAM is your computer's fast, temporary memory. It holds the data and programs your CPU is actively using, and that information is cleared when the system powers off. Desktop computers typically use DIMMs, while laptops use the smaller SO-DIMMs. You'll commonly see DDR3, DDR4, and DDR5. Each newer generation increases memory speed and bandwidth, with DDR5 being the newest of these three. RAM can also be ECC or non-ECC. ECC memory can detect and correct certain memory errors, making it common in servers and professional workstations. Non-ECC memory is the standard choice for most consumer desktops and laptops. Another important concept is memory channels. Single channel uses one memory channel, dual channel uses two, and supported high-end systems may use quad channel. More channels provide more memory bandwidth. Single channel is fine for basic computing, while dual channel provides better performance for multitasking, gaming, and productivity. Quad channel is mainly found in high-end desktop and workstation platforms where memory-heavy workloads can benefit from additional bandwidth.
And that's RAM. Simple, powerful, and essential.